4.7 notes, solar intensity and season. Orbit of the year around Sun and tilt on axis changes angle of Sun's rays and causes varying isolation, varying length of day, and varying seasons. The tilt of the Earth's axis stays fixed during orbit. Then we have a diagram that shows us the June and December solstice and March and September equinox. In June and December, north or south hemisphere is maximally tilted towards sun, and which causes summer or winter. Then we have March and September equinox, north and south hemisphere equally facing the sun. We can see equinox as equal, and here we have March equinox, December is solstice, September equinox, and June solstice diagram. It's representation of how sun affects all of them. Then we have the tilt of Earth's axis, which causes variation in angle of isolation, which changes intensity, length of day, and season. In March equinox, we have the equator, which receives more direct insolation. North and south hemisphere gets 12 hours of sunlight, and spring in north and fall in its south. And then we have December isosceles, just tilted at the max towards the sun, is the longest day in this, and is the start of summer, and the shortest day in north, which is the start of winter. Then we have the equator, which receives most insolation. North and south gets 12 hours of sunlight and fall in north and spring in south. Then we have June solstice, north is still the max towards sun, and we have the longest day in north and the start of summer, and the shortest day in the south, which is winter. Overall, this shows us that seasons are determined by tilt of Earth. We have albedo, which is the portion of light reflected by the surface and determines how much of the solar radiation is absorbed by the Earth's surface, which is equal to temperature. So because this affects temperature, we can know that surface with higher albedo is equal to reflect more light and absorb less. As an example, we have the mirror, which is all light reflected, and we have ice and snow. Then surfaces with low albedo, meaning it reflects less light and absorbs more. As an example, we have water, which absorbs more heat. Then we have surface is affected by albedo. More sunlight absorbed by surface equals more infrared radiation off, and which means hotter the surface will be. And then we have the urban heat island effect, which is urban areas are hotter than rural areas due to lower albedo of blacktop. Polar regions are colder due to higher albedo, and the Earth's albedo average is 30%. We have water, which has 10 to 60% albedo depending on sun's angle. Forests, we have 10 to 20% of albedo. Fresh snow, which has 80 to 95% of albedo. Asphalt, which is 5 to 10, and sea ice, which is 50 to 90. Then we have the FRQ, which is identify the season which is taking place in the northern hemisphere in this diagram, which is the winter, and describe how the tilt of the Earth's axis is responsible for the Earth's season. And it is because as the Earth orbits the sun, it is tilted on its axis, resulting to either the northern or south hemisphere being tilted closer to the sun and receiving more solar radiation at various points of the year.